Hi, I'm Abigail Swenor, and I work with Dr. Jugal Kalita on using random perturbations to mitigate adversarial attacks on NLP models. So the problem we're working with comes from the fact that there are vulnerabilities in NLP models because they're susceptible to adversarial attacks, which is exacerbated by the use of public data sets that have been scraped from the internet. These attack methods are becoming increasingly more difficult to detect, and they're using a wide variety of attack methods, which causes the need for generalization across these attack methods. Our approach has three key ideas. So we're working with random corrections or random perturbations from in our defense method. So we're using spell checking, dropping words, and synonym substitutions, as you can see here in this example. We're also working with the intuition that we might only need to look at some sentences to understand the sentiment of the input. So you can see here we only need this last sentence in this input to actually understand that it's a positive sentiment. Then we're also working with this element of randomness to balance out the random aspect as we're generalizing to multiple attack methods. We created two algorithms. This first algorithm is called a random perturbations defense. So you can see here up in the top in this blue, this is our original input, and we break that original input into its individual sentences. We take each of those individual sentences and perform random corrections to random tokens, and then we get what is called a replicate in the red there. We take all of our replicates and send them through a classifier, and we get an array of intermediate predictions. We take all of those predictions, perform majority voting to get the final prediction of what the sentiment of the input is. For our second algorithm, we call this increased randomness defense because it is very similar to the first, except we've added an additional step of randomness right to the front. So instead of looking at every single sentence, we're instead going to look at randomly selected sentences from that original input, perform those random corrections to get our replicates, and the rest of the algorithm proceeds the same as the first. These are the following results that we got from our experiments. We performed experiments on 7 different attack methods for both of these defense methods. So you can see here, those green entries all represent that our defense method was capable of bringing the model back up to its original accuracy within statistical significance. And then in that red there, actually, we were capable of bringing it up from 0% to 60% or 0 to 66%. We were not able to bring it back up to its full original accuracy. And you can see here that this shows that our method was successful at bringing our model back up to its original accuracy. And we're hoping to expand this to multi-class classification models, as well as some other languages besides English. We're currently working with Korean, possibly looking at Arabic. But this leaves the door open to work with randomness in defending NLP models against adversarial attacks. Thank you.